Welcome again to the ds-incubator, everyone. This is the series about getting data from websites. We already did one meetup last week where we overviewed basically the big two ways in which we can get data from websites. One is kind of scraping it, almost like a brute force approach, and the other one is using the tools when they exist that the websites or some websites provide for us to get data in a programmatic way. That is the topic that we're going to be covering next week. But today we're going to be getting into a little depth, not super deep, into the challenge of web scraping. And in particular, I want to thank CJ, who I used help desk, which is like a one-on-one meeting with someone. I used him to learn a bit about the topic that I'm trying to learn and teach here at the ds-incubator. So thanks, CJ. And today's meetup is going to be actually showing mainly one example that he shared with me a few days ago. But before I get into the meetup itself, let me first kind of set the context. We are going to be talking again about getting data from any website, even if it's one of those or one of most websites which do not provide a specific tool to get data from them. So it's basically the idea of scraping the data from them. And the objectives of today is to understand and implement the ethics of web scraping, something that I did not mention last time in the overview. So I missed that big topic, and CJ reminded me of that. And we're going to be not only pointing you to a resource to learn more about what are the ground rules for scraping data in an ethical way, but also we're going to see how we can implement those ground rules in a very easy way. Also, we're going to be scraping a website in two ways. One that is fairly easy, where what we see on the web page is what we get when we pull that page into R. And then in the same website, I'm going to show how sometimes what you see on the web page on the browser is not actually what you get, and then how you go about getting what you're actually seeing. So there is some dark magic that your web browser does, and we will have to replicate that with code. Then in general, I want to kind of convey the idea that scraping a website is quite challenging and is therefore not so scalable. So understand why then instead, if you have an API available, if you can find one that gives you the data that you want, it should be clear after today's meetup that that's the path of least resistance. So let's get into the topic. As usual, what you're reading here is the README file of the repository that hosts this series, to the use investing ds.webdata. And each chapter has its dedicated folder. So folder 2 is scraping. So let's get into that one. And now the README of that particular folder is the one that I'm going to be kind of walking through this meetup today. So as usual, we set up the packages that we're going to be using, so it's very clear upfront what tools you need installed if you want to reproduce what I'm showing here today. So we're going to be using the rvest package, which is the general web scraping tool in R, written by Hadley Wickham. Also, we're going to be using the polite package, which is actually recommended by the rvest package if you are scraping from one website multiple pages. So we're gonna be I'm gonna be pointing you to that website, to the website of the polite package for you to learn more, but also I'm gonna be showing you how you actually implement the very simple tools that polite provides to scrape websites politely. And then towards the end of the meetup, I'm gonna be using another package which is not on CRAN, so you have to get it with from GitHub instead. It is by RStudio and it's called Chromote for Chrome and Remote. So that will allow us to work in R as if we were working on a web browser, something similar to Chrome. So let's get started with the idea of ethics in web scraping. Someone wrote a very nice post that is, I think it's linked in the Polite website. So these ground rules, I encourage you to read them if you are going to be scraping websites yourself. It's very eloquently written as well, to the point that it inspired me to read a book of this author, so I'll probably do that soon. But here are a few ground rules, and the one that I would like to mention, the rest, is going to be a task for you if you're interested, but the one that I want to mention is maybe don't even start scraping. That's the one that I'm highlighting here. So it says that if you have a public API that provides the data that I'm looking for, I'll use it and avoid scraping altogether. So that paints a picture of how how much better it is to use data if there is such a tool that gives you data you want programmatically, as opposed to going through the brute force approach that I'm going to be showing today. So today's meetup is about that brute force approach, where we just go to the website and we try to identify something that we're interested in, and then we break, we kind of burn our brains trying to figure out how on earth we're going to get that data. But that's not the easy path, that's the difficult path. So I'm going to show you the hard way first. So the Polite R package basically distills the entire ground rules. That blog post is distilled in 3 points. So the Polite package focuses on first seeking permission before getting any data from the website. Then taking it slowly. So if you have to get data from a website, one thing is to get a little bit now and then another little bit in 1 or 2 seconds, and another thing is to try get 10 million things in 1 second, right? So if you are getting too much data too fast, then you may be breaking some of the policies that the website established for how much data and how often you can request it. In fact, the Polite package has explained in the website more or less how that actually is implemented. And I learned that websites, and I'm not sure if it's all of them, but they have this file called robots.txt. So apparently that is the file that the Polite package goes and consults to see what is allowed it to do, and then tries to do the request following that guideline. So that's the Polite approach. So I'm going to be showing you an example that comes from 2 Degrees Investing. The repository is private and is maintained by CJ, but the web scraping task that I'm going to be showing today is public because the data is available online publicly. So I don't think there's anything I have to hide here. So I'm excited about showing this example because it is one time where it was fairly easy for me to find that example because CJ pointed it to me, and which is something that I have been hearing from many of you often in ds-incubators, that unfortunately sometimes the examples that I find are not relevant to 2 degrees, and it's very hard to kind of translate like a very generic example to like the real life of us working at 2 degrees. So in this case, the example comes directly from a use case by 2 degrees. So if you have access to our private repos, then this link will take you to that place where CJ collects a bunch of very useful examples. But for now, this is I'm going to be kind of showing you the highlights of this example. So first, let me go here to R. Did I hear a hand up somewhere? No, not yet.
Sorry, just mentioning that I can give access to anyone to that repo if they want internally. It's just not meant for like very wide public consumption.
Thanks a lot. Yeah, that's depending on your case. Sometimes it is very useful to see how other people solved some kinds of challenges, so that you get inspired in finding your own solution. So, and that's the point of today. I'm going to be showing a problem that Seems easy to solve, and then it turns out that it's not so easy, and then how I go about that, or CJ went about that, and I copied his approach. But that also will kind of highlight that every problem, every scraping problem is unique, and that's why it's so hard to scale up solutions, because the fact that you figure out how to scrape one piece of data from one website doesn't mean that you already know how to scrape another piece of data from that same website or from another website. So it's extremely high, the cost that we pay in terms of the overhead to get any piece of data. Okay, so let's attach the packages that we're going to be working with today. So what you're reading here is the R Markdown file that is underlying what I showed you on the web browser a moment ago. So first, this is the URL that I would like to start working with. Let's open that URL on the web browser. So you go to this website. Let's wait for it to show information. And so you scroll down a little bit, and here is a table that shows countries that belong to what are defined as developed markets. So let's say that that's useful information. Instead of hard coding it in some script, we decide that this is a reliable website, and that every time we need those countries, we are going to get it from this source of data. So it's kind of dynamic. Every time we can get the latest and greatest information. So one thing I could do, I think I showed you this before. Let me go to a different web browser where I have another tool that is called the selector gadget. I presented this tool in the meetup last time, but I'm going to talk about this again. So this little tool here, I installed it as an extension to Chrome. It's called Selector Gadget. You can Google it and surely you'll find it. So if I click in that tool, let me first kind of scroll down to the table that I would like to scrape. Let's say that I want to get that table, so I can go to that little tool here. I click it, and now you see that there is, this tool appears here at the bottom. And as I move my cursor, I can select things. For example, I'm going to click on Canada as one example of the thing that I want to scrape. And that highlights every element that I want. It's kind of odd that the ones in white are actually highlighted, but they don't look like that. The way I know they are highlighted is because if I click on them again, I turn off some stuff, and that's not what I want. So trust me, they are all selected, so all the names here are selected. So what I get here in the tool is this thing called, this string of text called TD, which is basically some code. We're going to call that CSS, one kind of one language to describe elements on this page. TD, that is the description that I need to tell R which of all the information in this page I am interested in getting. So that sounds fairly easy, and indeed it is. So let's go to R. The first thing I am going to do is to get all the HTML that comes from this URL. So this is, I store the URL in this object called URL, and now we use the function read_HTML to get the entire page, including the piece that I want. But then the task will be to scrape the little bit that we want. But the first focus of this example is the politeness of the request. So the thing I want to highlight first, before I actually get into the task of extracting the piece of data that I want, is to remark that the first request that I did here is the simplest, but it's also impolite. Impolite because it's just getting the entire page. In this particular example, it's not a problem because it's just one request of one page. I'm not kind of overloading the server or anything. But that would be the impolite approach. I'm not saying who I am. I'm not establishing like any limit for how much data I want to extract. I just do it. The alternative is to replace the call to read HTML for two calls. One that is called bow, and then the other one that is called scrape. Those two functions come from the polite package, and that's all you need to do generally, plus some arguments that you can tweak. But for now, this is basically the way to implement the ground rules of polite scraping in R. So polite provides these two functions. It has a few more, but these are the two main functions that you need to know about. You simply replace read_HTML by these two, and you are doing a polite request. They do more or less the same thing. Not exactly, and I learned that the hard way, as I'm going to show later, because something that I thought it would work, it didn't, and I don't know why, but that's life. At least not yet. I don't know it yet. All I wanted to show about how to do things politely is this comparison between doing it impolitely, simply, and here doing it politely through the polite package. So that's it. Now, remember that I mentioned that when I went to the page and I identified that the piece of data that I want, it goes by the nickname TD, basically. That used that tool called selector gadget, and that string is all I need to tell R that is from everything in that page. Those are the elements that I want. So let me do this a little bigger for you to see it more clearly. So the first function in this pipe, HTML element, is focusing just on that, extracting that piece of data from the entire page, and then is transforming that into a text. So if I run that, what I see is something very similar, not quite what I want yet, but very similar to what I see on the page. So I'm getting everything, including, for example, the headings and including the white spaces here. So, okay, that was fairly easy, fairly straightforward. The page that I saw is what I got here, and I could extract the data quite straightforwardly. Still, if what I wanted was only the names of the countries, I need to do some wrangling here. I need to get rid of Americas, I need to get rid of Pacific, I need to get rid of white spaces. So let's say that it's not quite what I want. So also here I have only the developed markets, and I don't have the emerging markets. So instead, I'm gonna go to this other page of the same website and try scrape another couple of tables. So if I go to this other page, you see that we're still in the same website. And now I have these two pretty tables with color. One that gives me the developed markets and the other one that gives me the emerging markets. So that's more what I want. I wanted the two of them, so countries that belong to the developed markets and countries that belong to the emerging markets. So let's scrape those. So my naive approach is going to be to try to do the exact same thing that we did before. So with this, I acknowledge that it's 20 past. So Monica, can I ask you to move your reminder to 25 past? Hopefully a bit closer to the end.
All right.
Thank you. Okay, so remember, when I'm presented with this task, one thing I try first is I use the selector gadget, and I click on one thing that I want. So in this case, I click on Canada, and I already see that the tool populates this field with LI, which stands for list. So it's identifying every list element of the page, including the ones that I want, but also know that it includes some elements at the top that I do not want. So those are list elements, but not the ones that I want. So the selector gadget is pretty easy to use. If I click on something that is already selected in yellow, then it deselects it and every single element that is similar to that one. So with that, what I did was to basically select a specific thing that I want. And now I get this CSS code, pound boxes -container -1 space LI. That is the description of this piece of data that is the one that I want. And if I wanted to do the same thing for emerging markets, let's clear this up and let's start again. So I click, say, Brazil, and then deselect technology or any other item here. And then I get something very similar to what I saw before. In this case, the same thing, except that instead of a containers 1, I get a container 2. So that's pretty straightforward. That is what I'm going to be trying to use now in my naive approach. And this time, because I already learned how to do things politely and not politely, I decided to wrap that in a little function that I called scrape CSS. Basically, the magic is these 3 lines here. Once I have some HTML, then I get the elements that are specified by the CSS that I want to scrape, and then I convert that to text. And then the decision if the request is going to be polite or impolite, then it's going to be determined by the value that I pass to politely. So the default is going to be false. That's a helper function that I came up with just to show that it is fairly easy to write tools that simplify the process of scraping data. That the challenge is not so much in writing the code. The challenge is like figuring out what on earth you want to scrape and how to get that thing. So remember this string. It must look familiar to you now. So this is what describes the specific piece of data that I want. Number one belongs to developed market. So that's the one that I'm gonna store in this object called developed markets in R. And now I'm gonna use my function scrape CSS with a URL that I store. So I'm gonna show you the URL is the one that we're looking at the page. So if I now pipe that into scrape CSS, I would love to see the names of the countries, but instead I get character 0. I get nothing. So CJ was explaining to me a few days ago, that sometimes web pages, as I showed the previous example, show exactly what it is, and then you can get that page locally and get the data that you want. But sometimes life is not so good, and instead the website stores only some code that is going to be running to to render the page that you read. So basically what it means is that what has just happened, the reason why I didn't get what I wanted is because what I was seeing on the website, on the web page, is not what I get when I pull that page locally into my R session. So when I try to get these elements that I found already in the render version, they turn out not to exist in the version that I pulled. So the source of the code on the website does not contain the data that I want yet. It has to first be rendered, and that rendering process is kind of some kind of black magic that happens on the browser side, right? So what I need to do is to kind of fake a web browser into R and to ask that web browser to render that page as if I was interacting with it online, as opposed to just the naive approach that I just proved that it didn't work. So that is fairly ugly, I would say. So the magic is all of this, and I do not intend to try explain what all of this is doing, or even understanding what all of it is doing. It is using this package from RStudio called Chromote, which is not on CRAN yet, at least, and it's imitating a browser inside this R session, and it's going to render the page for me. What I want to highlight is thank you, thanks Monica. Luckily we are close to the end, so I think I'm gonna get through this. So what happens after I run all this code is that now the HTML object that I have created here in line 112 now has not the naive version of the page, but it has the actual render version of the page, as if I was looking at this page on the web browser on Chrome. So that means that I now can call my scrape CSS function and it should work. So as you see, it is there. And the same thing I could do with the emerging markets. All I need to do in this case is to change the number 1 for the number 2, as I showed you before, using the identify using the selector gadget. So if I run that, I am scraping the emerging markets. So as you can see, the code is very simple, but good luck trying to figure out all this dark magic that Chrome is doing and how to encode that. And every website may have its own kind of weirdness. So that is one of the takeaways that I'm going to be kind of phrasing in a moment. So before I go, I want to show that if I try to request the information in a polite way, unfortunately, it doesn't seem to work. So it looks like the polite package, at least with default arguments, works fine with pages that are already rendered. But when I try to use it, the polite approach in combination with this kind of dark magic of the web browser, I fail to scrape the data that I want. Maybe there is some argument I need to tweak, and maybe that gets me there, but I just don't know. So that's kind of a disclosure of this meetup. So here, there are some takeaways that I think could open up interesting conversations with analysts working with me and Linda in the projects that require scraping data. So first, scraping can be done in a polite way, an impolite way, and even in an illegal way, a dimension of the problem that we haven't considered before, and that's something that we need to kind of investigate. Before we decide how much data to get from some particular website, we need to see if it's at all legal to do that. Another takeaway is that scraping a website isn't just easy or hard. It depends on the specific data that you want. I showed you that in the same website, in the example that I showed today, I scraped two different tables. The first one was straightforward to scrape because what I was seeing on the web page was already what I was getting locally in R, and I could then get what I wanted. But then in the same website, a different table was not being rendered or was being rendered on the side of the web browser. So I needed some dark magic to make that happen and to scrape that piece of data. So that means that we have to have conversation with analysts about what specific piece of data they want from a specific website before we can determine if it's easy or hard to get. It's not as simple as saying this website is scrapeable or is not. We need to know what piece of data you want. Third, that the overhead to scrape each specific website is high. So we need a human, we need like me, Linda, or someone else, CJ, helping us, trying to figure out how to get that data. Then once it's done, it might be easier. It might be kind of easy to get data over and over, and maybe not, because if the website is not intending users to get the data to scrape it, they may change the way they encode things, and an analysis that runs today may break in the future. So that means that the challenge that we are solving today may not be sustainable in the future unless we have the resources to go back to the code and adapt it as it fails. And finally, I want to kind of finish how I ended. The idea that if we discover that the website does provide a tool to get the data directly, which we call an API, then we should go for it every single time, as opposed to trying the brute force approach. So lastly, I would like to highlight two resources. One is a work in progress that I'm writing.
It's 30 past already.
Thank you, Monica. So the document is a cognitive tool to try figure out if a website is easy or hard to get data from, and I'm working on it. It's not finished, but you can start having a look at it and maybe provide some feedback to improve it. And finally, there is this issue that I'm using to collect information about how to find useful APIs, and I encourage very strongly to any analyst intending to get data from the web, to go and explore if they can find APIs that sound like they could have useful information. Very sorry that it's so late. Maybe what I'm gonna do is invite whoever needs to go on to another meeting to just do it, and then whoever wants and can stay, hang out here for questions and comments. And CJ has the hand raised, so hear you.
I have two comments. I'll try to make them quick. One, I think that the reason why your politely code is not working in this second example that you used is because you've already stored the HTML in an object. So the function that you wrote to wrap the politely commands is working on local data, essentially. And the politely functions are intended to work on making this request to a web server. So in the second case that you showed there's no need, and indeed there's no, it's not happening that it's communicating with the server at all. So the politely functions can't really do what they're designed to do in that case.
I get it.
And then I thought maybe to demystify the black magic a bit, because you wrote the document in R Markdown, and some of you here also might be more familiar with R Markdown. You might be familiar with the idea of adding in the code blocks of an R Markdown file. For instance, an object, like you could add the object empty cars. And when that rendered, when you click the knit button to render that file, the result of that would be like the printed output of what the contents of empty cars is. So it's a corollary to, like, if you tried to scrape that rendered R Markdown file, you might want to look for the name of a vehicle or something that's inside that object. But if you get just the HTML file, you would only see empty cars. You wouldn't see any of the contents within inside of it. So this is very similar to what's happening on a lot of websites that are using JavaScript to render them. The HTML just defines the structure of the page and which JavaScript to run, but what the JavaScript actually does in terms of rendering the empty cars object is not seen in the HTML itself. It's not seen until that is rendered and finished. So this is maybe gives a good example that is closer to something that you're familiar with.
Awesome analogy, I love it, yes. Mm-hmm. Do we have any other comments or questions here in the audience? Okay, thank you very much, everyone, for joining us today. I think there's gonna be maybe one more meetup in this series, and then a blog post that is a follow-up of the entire series, where I digest what I learned on hindsight. Hopefully that blog post will be very condensed. It will have pointers to a lot of information that I think is useful now that I know it. So yeah, I'll see you next week, and then advertise that blog post for you to read and contribute with feedback. Thanks very much for joining.
Thank you, Marvel. Bye.